Brian is a lab director. 30 years ago, there were a few things that Brian did that he would never do today. Brian wore his fanny pack everywhere he went. His parachute pants were totally awesome, and his mullet was pretty darn rad. But this was 30 years ago, when mullets were the gold standard, and everyone still thought Pluto was a planet. The same is true with his lab. There are methods Brian's lab has been using for almost 30 years, but today, with a focus on patient results, Brian follows a new method and has put the old one away. About 30 years ago, Brian began using the HpLC method to analyze HbA1c results. HpLC comprises methods that are based on the difference in charge of the molecules, such as cation exchange high-performance liquid chromatography and capillary electrophoresis. Here is a typical chromatogram that Brian would see. HpLC must identify all Hb variants present and their glycated forms, which can be problematic given that all molecules with the same electrical charge will be eluted at the same retention time, possibly leading to coelution. This big peak, HbA, is hiding another peak behind it, which Brian can't see. So, what else is he missing? It's a lot like being asked to visually measure how much water is in a glass without knowing if another clear liquid has been added. Your visual measurement could be wrong. The chances of being wrong, not knowing if another liquid has been added, is a lot like a variant co-eluting with an HbA1c or HbA peak on a chromatogram. It's there, you just can't see it, which might cause an overestimation or underestimation of the result. Because there are more than 1,100 known human Hb variants, and approximately 7% of the world's population are carriers of these variants, the lack of clinical specificity when utilizing HpLC prevents it from being adopted as a reference method for the IFCC reference system. And although some people may feel that HpLC is needed to identify Hb variants, in some cases, variants may be identified only by ESMS, or by sequencing the expressed globin genes. The lack of specificity in HpLC measurement leads to the unknown. How many variants are being missed because of coelution of the molecules? Will you ever know? The issue prompted the development of alternative methods. The goal of a physician when ordering an HbA1c test is to get an accurate HbA1c result. Thanks to Roche's quant methodology, this makes it all possible. The Roche quant HbA1c assay specifically detects the first 4 amino acids of the N-terminal end of the hemoglobin beta chain, and with this it detects the real analyte as defined by the IFCC as representing the only valid anchor for HbA1c testing. Furthermore, this choice of antibody is the reason why Hb variants such as HbS, HbE, HbC, and HbD do not affect the HbA1c result given by this test as compared to the HpLC method. The mutations resulting in the common Hb variants are not contained within the region detected by the antibody, the first 4 amino acids from the N-terminal end of the hemoglobin beta chain. What does this mean for Brian's laboratory and organization? First, doctors receive accurate results reporting, even in the presence of hemoglobin variants, allowing for earlier treatment because Hb variant interference does not complicate the measurement and result in extensive genetic testing. It may also represent a time and cost savings to Brian's lab. No post-analytical steps to verify results from a chromatogram, no additional training of techs and FTEs, no standalone HbA1c system taking up valuable lab space, eliminating additional service contracts and maintenance. Reallocation of labor and a more efficient operation, fewer supplies and storage requirements. Ultimately, this leads to overall workflow improvements and maybe give you some time to actually take a break. Brian now recommends the quant methodology to any lab managers looking to improve patient results and lab efficiency. Like Brian, you've probably put away your parachute pants and got rid of your mullet. Now, isn't it about time you take the next step and upgrade to the quant methodology from Roche?